An urn contains 3 red balls and 2 blue balls. 2 balls are randomly selected, one after the other, with replacement. Let's add one after the other to be sure. Two balls are randomly selected, one after the other, with replacement. Let X be the number of red balls. Let X be the number of red balls. Find the probability distribution of X. Compute the mean, variance, and standard deviation. So you pick 2 balls, one after the other. Then you count the number of red balls. We want to define the probability distribution of X and the mean, compute the mean, the variance, and standard deviation. So what are the possible values of X? Number of red balls. What are the possible values of X? There are 2 balls. What are the possible number of red balls? You can have 3. There are only 2 balls. How many of them are red? How many of them can be red? You can have 2. What else? 1 or 0. So X is 0, 1, and 2. Let's make a tree diagram. The first ball could be red or blue. If the first is red, the second could be red or blue. Red or blue. So here we have, this outcome will be red, red. This will be red, blue. This will be blue, red. This will be blue. So the probability distribution will be 0, 1, 2. So what's the probability that we will get no blue? So to get those probability, we need to complete the tree diagram. What is the probability that the first ball is red? What is the probability that the first ball you pick is red? There are 3 red balls and 2 blue balls. If you pick one, what is the probability that it is red? Yes? Can somebody say it loud? 3 out of 5. Is that correct for everybody? There are 5 balls, 3 are red. Now, If the first ball is red, and then you replace it, we say with replacement, you replace it. What is the probability that the second ball will be red? If the first ball is blue and you replace it, what is the probability that the second will be red? So this is the outcome with no red. What is the probability that we get blue? What is the probability for blue? Hmm? I'm waiting. Any suggestion? First ball is blue, second ball is blue. What is that probability? That's what we get, 0 red. 0 red. What is the probability for 0 red? Any suggestion? 4 over 25, is that correct? 4 over 25. Because this is blue, given the first one is blue. So we have blue, given that the first one is blue. So blue on blue is first blue times second blue, given the first one is blue, which is this time. So you make a tree diagram. That's how it happens. What is the probability that one is red? That is this one or this? What is the probability for this one? This outcome? Say it loud. Can you just say it loud? Whoever. Yes? 6 out of 25. What about this one? The same. So what do we get here? What? It's either this or that. And the last one? So we'll find a mean. Okay, first, somebody could ask me, why don't we just say 1 over 4? Because there are 4 outcomes. Because red and blue are not equally likely. I wanted to say 3, then I say if I say 3, you will not perceive this aspect of it. The formula we gave in chapter 4 about number of E divided by number of S is for equally likely outcome. Like when you toss a coin, you roll a die. So the mean of X will be 0 times 4 over 25, 1 times 12 over 25, 2 times 9 over 25. Is equal to 20. Which is by 5. That is the mean. Question? Anybody has a question so far? Now to find the variance, we need the mean of the square. Find the variance, we need the mean of the square. Remember that. That means we square each value and multiply by the probability. We square 0 and get 0. Square 1 is 1 times 12 over 25. Square 2, we get 4 times 9. So what I've done is 0 times 4 over 25 is 0. 1 times 12 over 29. Then for 2, we square 2 and we get 4. It's 4 times 9 that is giving us the 36. Okay, 48 over 25. So the variance of x is e of x squared minus e of x, which is 48, minus the square of this, and the standard deviation, sigma is square root of 12 over 25. 12 is 4 times 3, so this will be 2 square root of 3 over 20. You can use your calculator to get the decimal number that you can write. So I did this so that we can review what mean, variance, and standard deviation is. But I want you also to understand how to interpret a problem, transform it into a random variable, and do the probability distribution. Linear transformation of a random. Linear transformation of a random variable. Let x be a random variable. With mean and standard deviation sigma. And about ax plus b is called the linear transformation of x. The mean of L is A times the mean of x plus b, which is A mu. Remember, mu is the same as E of x. And the variance of L is A squared times the variance of x. The standard deviation of L is the absolute value of A and standard deviation. example, let x be a random variable with mean mu equal to 3 and standard deviation 2. Define L as 4x minus 5. Find the mean, variance, and standard deviation of x. So if you have a question like this, the mean of n is 4 times mean of x minus 5. Mean of x is 3. This is 4 times 3 minus 5. 4 minus 5 equals to 7. And the variance of L is 4 squared variance of x, which is 16 times. The standard deviation of x is 2, so the variance of x is 2 squared, which is 16 times 4 equals to 60. And the standard deviation of L will be square root of 64, which is 8. Observe that we could just say that A equals to 4, and we do 4 times 2 to get that 8. We don't need to do that. And I pointed that down there. The standard deviation is the absolute value of the number in front of x. In your PowerPoint is b that's in the front of x. Just the same thing. Now linear combination, let me write it here. Linear combination. We might combine two random variables x and y. Let x and y be two independent x and y be two independent random variables with mean g of x equals to 2, standard deviation of x equals to 2, mean of y equals to 4, standard deviation of y equals to 2. I'm sorry. We are going to get to this. I get this, but I want to use just the mean. Then W equal to AX plus BY is a linear combination of X and Y. The mean of W is A, mean of X, plus mean of Y. And the variance of W is A squared variance of x is b squared variance of y. The standard deviation of W is equal to a squared variance of x, b squared variance. So if we find independent random variable, we can also find the variance of their linear combination. So now let W equals to x plus y. Here A equals to 1 and B equals to 1. We'll find the mean, the variance and standard deviation of W. So the mean of W will be mean of x plus mean of y. Remember that I said the mean of x is 3, the standard deviation of x is 2, the mean of y is 4, the standard deviation of y is 3. So here we will have 3 plus 4 equal to 7. And the variance of W will be variance of x plus variance of y, because A and B here are 1. So when we square it, it remains 1. So which is 2 squared plus 3 squared. Standard deviation. So we want to observe here that we have two random variables x and y combined with A and B. We call it a linear combination of x and y. Now, let t be equal to x minus y. Then E of t is E of x minus E of y, which is 3 minus 4 equal to minus 1. And the variance of t is variance of x minus variance of y. Not minus, plus, I'm sorry, plus variance of y. And that is what makes the difference between variance and x and mean. For mean, we maintain the minus, but for variance, we change it to plus, because we do plus the square of negative 1, so which is 2 squared plus 3 squared. And the standard deviation of t here is square root of 30. Now let z be equal to y minus 2x. Here I made another one, z equals to y minus 2x. Then E of z is E of y minus 2 E of x. E of y is 4. E of x is 3. 4 minus 6 equal to minus 2. And the variance of z is variance of y plus 2 square variance of x. This is plus, actually it's minus 2. Let me put it correctly, minus 2 square. And you know when you square minus, it becomes plus. So this is variance of y is 4 square. 2 square here is 4. And variance of x is 2 square. So this is 16 plus 16. This is 4 times 4 equals to 32. So the standard deviation of z is square root of 32. I want to remind you that the take-home problem I put it today, what you had before has been replaced. So be careful. If you had downloaded the take-home problem, check it out again. Take-home problem for chapter 5, not chapter 4. So we have covered distributions. We know what a probability distribution is, how to find a mean, the variance, and standard deviation. We also know how to combine random variables, linear transformations, and linear combinations. We want to look into a special type of probability distribution, which is called the binomial distribution. Into the binomial distribution. Point 2, point 1. Binomial experiment. A binomial experiment consists of first a fixed number of independent trials. A binomial experiment consists of a fixed number of independent trials. So there is a fixed number of independent trials, and just the quantity times. Each trial has exactly 2 outcomes. Success and failure. Each trial has exactly 2 outcomes, success and failure. The probability of success at each outcome remain the same, and is denoted by P. P equals to probability of success. And Q is 1 minus P is the probability of failure. Use that also. We'll be using those letters P and Q, T for success, Q for probability of failure. Now we will say that X is the number of success. X, the number of success, is called the binomial random variable. X, binomial random variable, generally has value 0, 1, 2. If there are n trials up to n. A binomial random variable is denoted by binomial random variable is fully defined by the knowledge of the number of trials and the probability of success at each trial. Example, the car is tossed 10 times. Let success be had 10, n equals to 10, and p equals to 5. A die is rolled 6 times. Let success be having a number less than 1. Then n equals to 6, and p equals to 1 over 3. Like when you roll a die, the probability of getting a number less than 3 is 1 over 3. So each time we have a binomial distribution, we want to know how many success do we have? What is the probability of success? A probability distribution the probability distribution of a binomial random variable is called a binomial distribution. If X is a binomial distribution, then the probability that X is equal to a number R is n combination R times PR times Q n minus R. By Q is 1 minus P. The if I write it again as n factorial r factorial n minus r factorial PR. This is the formula for a binomial. I want to use an example to illustrate how we get this form. Then this will 6 times. But success success is a number less than 10. Then n equals to 6 and p equals to 1. What is the probability? That x equals to 0, x equals to 1, x equals to x equals to 2. Success is the number on the die is less than 3. For this one, it might be easy to find. We want no success. That means we want here the event is failure, 6 failure. So the probability that x equals to 0 is the probability of we have failure 6 times. Does that make sense? So because the trials are independent, this will be probability of failure. 1, 2, 3, 4. Which is 1 over 3. So 2 over 3 failure. Success is 1 over 3. Failure is 2 over 3. So we can find that one. Now, how many times are we going to get this outcome of failure all this true? How many times are we going to get the outcome with failure all true? If there are 6 trials, how many of the outcome will have failure in all cases? No idea? If there were 3, how many will have outcome? F, all 3. How many outcomes are there? Just say anything you think of. Then we have boy, 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 girl, boy. How many outcomes is all the same? Alan? I thought I had something. Somebody should give me an answer. How many outcomes are all failing? 1, right? There is only 1 outcome, all failing. So this answer is what I should put here. And if we want to have success 6 times, how many outcomes will we have? 1. So these are where we will have trouble. And that's why I would like to explain. Maybe we should try for 1. 1 will be probability that x equals to 1. We could have from x equals to 1, we can have failure, success, failure, 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 failure. This is 1. Success, failure, 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 failure. Failure, 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 success. How many outcomes do you think we can have? How many? 6. 6, right? And what will be the probability for this one? Failure, success, failure, 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 failure. I will count the number of failures. 2/3. Doesn't work. The answer is the same for this. The same for this. So one success is either of these 6 cases. So this probability will be 6 times 2/3. Now, suppose I want for 2. An outcome could be success, failure, failure, success, failure, failure. This is one outcome. Another outcome could be failure, success, failure, success, failure, success. No, failure, failure. You want 2 successes. At this point, we will understand that the probability depends only on the number of success. Have you noticed that? The probability depends on the number of success. So the probability for x equals to 2 will be 2/3 number of failure, which is 4, times 1/2. Now we will multiply this number by the number of outcomes having 2 success. So now we want to know how many outcomes have 2 success. We may not be able to list them all like for 0 and 1, but we will understand that to get an outcome with 2 success, we just need to pick 2 positions out of the 6 and assign success to it. So we will say, if this is the first position, second, third, fourth, fifth, 6, choosing 2 numbers out of these 6 at random will give us an outcome with 2 success. And the number of ways to choose 2 out of 6 numbers at random is 6 combination 2. So we write here 6 combination. So that is the explanation for the general formula. having understand this, we are not going to be using this formula because I don't have the time to be doing all this computation. We will be using calculator. So let's use calculator to compute this. So to use your calculator, you will go to second function. You will see VRS, which is for distribution. Then you will choose binomial PDF. All right, N, E, R of X, the number of success. So let's do this for probability. Let's say that X 6 1/3. And we want the probability that X is equal to 4. Number of trial is 6. Probability of success is 1/3. And X or R equals to 4, depending on where you are following. I want you to use your calculator. If you have trouble with using your calculator, let me know. For some of you, your calculator will just have number of trial, you put 6. Probability of success, 1/3. Number that you want, like R equals to or X equals to, number of success, you just put 4. For some of you, a parenthesis will open when you do that, and you write 6, 1/3, 4. So anybody has an answer? Has anybody done this? What do you have? So if anybody has this, so please try, because we will be using calculator. We are moving as you, from now we are going to be using this calculator more and more. So practice using it. So this is when I want probability that X is equal to 4. What if I want the probability that X is less than or equal to 4? If I say X is less than or equal to 4, you will do binomial CDF. 6, 1/3. CDF is called cumulative distribution function. It's like we did cumulative frequency, the cumulative distribution. It will add the probability onto where you are. In your table, you have a binomial probability distribution that you may want to learn how to read. But you have calculator, that's why I'm not, everybody here has a calculator. You are inside. So if you have a calculator, you don't need to learn how to read the table because this will be good. So what do we have here? Anybody has 0.8? 0.1. You choose CDF. You just do the same thing, but choose CDF. It's a PDF. I just want you to know what the CDF stands for. instead of doing P of 0 plus P of 1 plus P of 2 plus P of 3 plus P of 4, you use CDF. So what answer do you have? So 5.3. Additional properties of binomial distribution. Let X and P be a binomial distribution then the mean of X is E of X equal to NP. The variance of X is variance of X equal to NPQ, and the standard deviation of X is sigma X equal to square root of NPQ. Here, what we call Q is 1 minus 1. So I will just do the example that we have here. Example of X 6 1 over 3. E of X is 6 times 1 over 3. It is 2. The variance of X is NPQ, which is 6 times 1 over 3 times 2 over 3. Here, which is 6 over 3, you can write this as 12 over 9 by 3. 12 divided by 3 is 4. The standard deviation. So when you have a binomial distribution problem, you want to know what is the number of trials, what is the probability of success, and you can use it to find the mean, the variance, and the standard deviation. The quota problem is a common problem you may encounter in binomial distribution. In the quota problem, you are given a confidence level for which you should have a certain minimum number of success. For example, how many courses should you take to be able to pass at least 3 of them? That is what we call a quota problem. The quota problem what is the number of success, the number of trials achieve a quota. A quota is a minimum number of success. At a certain level of confidence. In general, that's what it is. We'll give you an example. We will solve that example. So in this example, we want to find the number of jump balls that should be brought if we know that the probability of success is 65%, and we want to be 95% confident to get at least 4 good ones. So jump balls are balls that, let's think about jump cars. Cars that are considered loss, complete loss. Like some people go to junk yards and buy those cars to remodel them, to remake them. They call it refurbished and to resell. Because you buy them without knowing the quality of the car. Sometimes you can do well, sometimes you may not. So if the probability of success, for example, if P is equal to 0.65, what is the probability that the number of success will be at least 4? What is the no? If you know that the probability that the number of success is at least 4 is 0.95. When we say that the confidence level is 0.95, means that you have a probability of getting that by more than 0.95. What is N? This is our question. What is N? So that the probability that X is greater than or equal to 0.95. I'm sorry, X is greater than or equal to 4 is greater than 0.95. So what we are going to do actually is, because X greater than or equal to 4 means 4, 5, 6, up to N. But we don't know N. So we will take the opposite of this. In solving quarter problem, you take the opposite. We will say that this probability is the same as 1 minus probability that X is less than 4. It's greater than 0.95. In that case, we know the numbers that are less than 4, 0, 1, 2, 3. And this, we can write it again as 1 minus 0.95 is greater than or equal to probability that X is less than 4. And the probability that X is less than 4 is the same thing as probability that X is less than or equal to 3, or cumulative. In cumulative, we have less than or equal to. I just changed this to that so that we. So what is N? So that the probability that X is less than or equal to 3 is less than or equal to 0.5. So this is how you transform the quota problem to get an answer. If we were using the textbook, how many of you have textbook here? You have your textbook? Okay. If you have your textbook, you can use it because there is a binomial distribution table at the back of your textbook, or you can use your calculator. You want to use calculator because more people have calculator. So we are going to look for the minimum number of trials. Because you don't want, if you know that you can have at least 4, if you have at least 4, you will make a lot of profit. You just want to buy as few as possible so that at least 4 will be good. Okay. For example, if you are working somewhere and they tell you once you sell at least 4 of them, you are done. You have met your quota. You just want to get the minimum number of customers so that you can sell at least 4. But even if you sell 10, that doesn't make it. So we will start with trying. We will try with 8. Let's start with 8. If n equals to 8, what is the probability that x is less than or equals to 3? You take n equals to 8, p equals to 0.65, and you do binomial CDF for 8, 0.65, and 3. Let's try 8 and let's know what you get for 8. Anybody has an answer for 8? Once we finish, we are free to. So let's just finish. Anyone to 8, what do you have? 106. Does it satisfy this? Is it less than or equal to 0.05? Anybody else has 0.06? Anybody has 0.06? Nobody tried? Somebody got something else? Okay, let's do it together. That's what we can do. If you don't understand, ask me the question. I am saying put n equals to 8, p equals to 0.65, and 3. What do you get with CDF? Yes. 0.106. Anybody has 0.106? Okay, then we move. So does this satisfy this? Maybe you should check again. Did you use CDF? You go to second function, distribution, binomial, CDF. Now let's do 9. Binomial CDF, 9.65, 3. But this does not work. 9.653. If you have a number, let me know. Yes. 0.05. Nothing else. It's very important. It's okay. That tells us that it's more. Right? Okay. Now, binomial CDF 10. It will be reducing as we are increasing the number. Anybody? 0.026. Does it satisfy this? So we are good. 10 is good. So if you try 8 and 8 works, don't go to 9, go to 7. You take one number and you start from there. If it works, go below. If it fails, go above. Okay. You will go over the geometric, and I've done an example of geometric. I will mention it again on Tuesday, but I think we will keep it optional, meaning that it's not going to be on the exam, but I will explain what geometric and Poisson distributions are. Is it geometric? Geometric and Poisson distribution on Tuesday. We have done an example of geometrics when you say the number of trials to get the first success. That is geometric distribution.